Hi guys, welcome to this Easy Maths video, and today we are looking at the AS level Pure Maths and Mechanics paper from OCR. This is for the new A-level Maths specification, and this is the second AS exam. It is an hour and 30 minutes. Calculator is allowed. The paper is made up of a total of 75 marks, and it is important to know that for all of the mechanics questions we will be approximating g, the acceleration due to gravity, as 9.8 meters per second squared. Question 1a. The diagram below shows the graph of y equals f of x. Part I, on the diagram in the printed answer book, draw the graph of y equals function x plus 3. We need to draw the graph of y equals function x plus 3. So you should notice straight away that y equals f of x to y equals function x plus 3 is some form of transformation. And you should be able to see that it is a translation, as we've got this plus 3 value next to the variable x. Now we just need to identify whether this is a translation parallel to the x-axis or whether it's a translation parallel to the y-axis. If our translation is inside the function, we say that it's a translation parallel to the x-axis. Now this is the transformation that is kind of counterintuitive. So you might think, because our function is of x plus 3, so we're going to move all of our values of x 3 units in the positive x direction, when actually we're going to move all of our x values 3 units to the left, which is parallel to the negative x direction. So we're going to have transformation 3 units left parallel to the x-axis. So this graph of y equals f of x is made up of 3 points. We've got 1 point here, another point here, and another point here. So we need to translate each of these points. So the first point is at the origin, which is 0, 0. So in order to translate the x-coordinate 3 units to the left, I'm going to get minus 3, 0, which is going to be here. Next coordinate is the coordinate 1, 2. Remember, I'm only looking at the x value, so I need to translate 1 3 units to the left, and that is going to be minus 2. So it's going to have the coordinate minus 2, 2. My last coordinate is the point 2, 0. I need to translate my x coordinate 3 units to the left, so I'm going to end up with the point minus 1, 0. And now I can just connect these points. And as you can see, that is my translated function. Part 2 says describe fully the transformation which transforms the graph of y equals f of x to the graph of y equals minus f of x. Okay, so this is a transformation where we have a negative sign that is either outside of our function or it could be inside of our function. And these transformations are known as reflections. A negative sign outside of the function means that the graph is reflected in the x-axis. Because what's going to happen is, if you think about it, for any graph, all of our x values are going to stay the same, but when we input any x values into this function, our y values are all going to become negative. So in order for that to happen, there must be a reflection in the x-axis. So we say, part I, the graph of y equals function x is reflected in the x-axis in order to get y equals negative f of x. Part B says the point 2, 3 lies on the graph of y equals g of x. State the coordinates of its image when y equals g of x is transformed to y equals 4 g of x. So, this first example is y equals 4 g of x. Now, when we've got functions in the form of y equals a f of x, this constant a is described as an enlargement parallel to the y-axis, where a is our scale factor. So as you can see in this example, we're going to have an enlargement of y equals g of x with a scale factor of 4 parallel to the y-axis. So what's going to happen is when we have a scale factor parallel to the y-axis, our x-coordinates are going to stay the same, but our y values are all going to be multiplied by 4. So in this case, the coordinate 2, 3, the 2 will stay the same, but the 3 will become 3 times 4, which is 12. So that's the first coordinate. The second part is state the coordinates of its image when y equals g of x is transformed to y equals g of 4x. Now, this scale factor of 4 is inside our function. And if it's inside our function, it means that we're going to have a stretch parallel to the x-axis. But we've got to be careful here, because if we have functions in the form of y equals function a of x, where a is our scale factor, the scale factor is not equal to a, it's equal to 1 over a. It's equal to the inverse of a. So what this means is, if we look at the coordinates, all of our y values are going to stay the same, but our x values are all going to be divided by 4 or multiplied by a quarter. So in this case, we've got the point 2, 3. Remember, y is going to stay the same, so that's going to be 3, but we're going to divide 2 by 4, and we get a half. So our coordinate is a half 3. Question 2, we need to solve the equation 2 cos squared x equals 2 minus sine x for the x values between 0 degrees and 180 degrees. So, if we write out this equation, so the first thing we need to do is we need to rewrite cos squared x in terms of sine. So the way we need to do that is we need to think about our trig identities. And there's 2 trig identities that you need to remember for the AS level maths qualification. And one of them being cos squared x plus sine squared x is equal to 1, or equivalent to 1. So what we can do is we can rearrange this identity to get a value for cos squared x in terms of sine. So we get cos squared x equals, if we subtract sine squared x, we're going to get 1 minus sine squared x. Okay, so now what I can do is I can substitute 1 minus sine squared x into cos squared x. So I'm going to get 2 all multiplied by 1 minus sine squared x, which is equal to 2 minus sine x. If I expand the bracket on the left hand side, I'm going to get 2 minus 2 sine squared x, which equals 2 minus sine x. Now I need to bring all of my terms over to one side. So what I'm going to do is I'm going to move minus 2 sine squared x over to the right hand side. So I'm going to get 2 equals 2 plus 2 sine squared x minus sine x. And now I can just subtract 2 from both sides to get rid of that 2. So I'm going to get 2 sine squared x minus sine x equals 0. Now you should be able to see on the left hand side I've got a common factor of sine x, so I can factorise that out. So I get sine x all multiplied by 2 sine x minus 1 equals 0. Now what this means, if I was to divide through by 2 sine x minus 1, one of my values of sine x would be equal to 0. So I need to make note of that. But if I divide through by sine x, I'm going to get 2 sine x minus 1 is equal to 0. Now I can solve this equation for sine x, because I can add 1 to both sides, so I get 2 sine x equals 1, and then I can divide both sides by 2, so I get sine x equals a half. Okay, so I've got 2 values for sine x. I've got 0 and a half. But I'm not interested in my values for sine x, I'm interested in my values for x. Now what I'm going to do is I'm going to draw the graph of sine x. Which looks something like this. where we've got a y value of 1 here, and a y value of -1 here. And on our x-axis, this is obviously going to be 0 degrees. Here is 180 degrees, and here is 360 degrees. Now, I want to find a value for x. So if we use sine x equals 0, if I apply the inverse of sine to both sides, I'm going to get x equals the inverse of sine of 0. The inverse of sine, when y is 0, x is 0. So x is equal to 0. However, you should be able to see on the graph that when x is 180 degrees, our value of y is also 0. So we can also say, or x equals 180 degrees. To work out our values of x for sine x equals a half, we need to do the inverse of sine of both sides. So we get x equals the inverse of sine of a half. Now, if you were to work that out on your calculator, you will get a value of x as 30 degrees. So if I was to plot that on our graph, it would be roughly here, and I would get a corresponding y value of a half. Now remember, if we concentrate on our sine graph between 0 and 180 degrees, our graph is symmetrical when x is 90 degrees. So what's going to happen is we're actually going to have two x values between 0 and 180 when y is a half. And because this graph is symmetrical, what that means is if my last value of x for this function is 180, if we consider all of our x values between 0 and 180, I'm going to need to subtract 30 in order to work out what my other x value is. So that's going to give me a value of 150 degrees. So we can say our other x value must be 150 degrees. So as you can see, we have ended up with four x values. X equals 0, 30 degrees, 150 degrees, or 180 degrees. Question 3 says the number of members of a social networking site is modelled by m equals 150 e to the power of 2t, where m is the number of members and t is the time in weeks after the launch of the site. Part A says state what this model implies about the relationship between m and the rate of change of m. Okay, so our model is represented by the equation m equals 150 e to the power of 2t. We need to find the relationship between m and the rate of change of m. Okay, so the rate of change of m is just the derivative of m. So the derivative is going to be with respect to time. So that's going to be dm by dt. So that's what we need to try and find. So if we were to differentiate this function, we would get dm by dt is equal to 300 e to the power of 2t. So what we need to do is we need to compare m against dm by dt. And what you should be able to see is that dm by dt is just twice the value of m. So if you like, dm by dt is equal to 2m. So if I was going to summarise this, I could say that the rate of change of the number of members, because remember in the exam I'm going to have to write this in context, over a certain number of weeks is proportional to twice the number of members. Part B says what is the significance of the integer 150 in the model? If we look at the equation again, m equals 150 e to the power of 2t, well, the value of 150, if we want m to just equal 150, you should be able to see that means that t would have to equal 0. And remember, t is time, the amount of time in weeks. So t is equal to 0 weeks, and m is our number of members. Well, what that means is, well, if m is equal to 150 when t is 0, that must mean that there were 150 members when they first launched the social networking site. So we can say when t equals 0, 150 is the number of members at the start of the launch for the social networking site. Part C says find the week in which the model predicts that the number of members first exceeds 60,000. So we're going to need to use our equation again. M equals 150 e to the power 2t. So we need to find the number of weeks at which the number of members exceeds 60,000. So that means m is going to be greater than 60,000. So what we can do is we can use our equation and say that 150 e to the power of 2t is going to be greater than 60,000. And now we've got an inequality where we just need to solve for t. So in order to solve this, we need to divide both sides of the inequality by 150. So we should get e to the power of 2t is greater than 400. Now we've got an exponential inequality here, and the way to solve this is to take the natural log of both sides. Because remember, the natural log is the inverse operation of e. So if I was going to take the natural log of e to the power of 2t, and that's greater than the natural log of 400, then what I can do is I can use my laws of logarithms to then bring the power of 2t down to the front. So I get 2t and then the natural log of e, which is greater than the natural log of 400. And remember, I said the natural log is the inverse of e. So if I do the natural log multiplied by e, I get 1. So now I've just got 2t multiplied by 1, which is 2t, and that's greater than the natural log of 400. And I can divide both sides by 2, so I get t is greater than the natural log of 400 over 2. And now I can type that result into my calculator. I can see what I get. So I get t is greater than 2.9957322774. And that will probably keep on recurring. Now, t is a value that is greater than this result. Okay, but I don't define the number of weeks as a decimal place. So what I'm going to say is t must be equal to 3 weeks. So if we were going to summarize this, we could say t must be the third week in which the number of members will exceed 60,000. Okay. And then part D says the social networking site only expects to attract 60,000 members. Suggest how the model could be refined to take account of this. So if the social networking site only expects to attract 60,000 members, what that means is we need to put a restriction on the amount of time. Now, in the previous question, we just worked out that it's going to take 3 weeks for them to reach 60,000 members or more. So what we can say is in part D, the time taken should only be restricted to 3 weeks. So in other words, we could write this as an inequality like this. So the value of t is between 0 and 3. Question 4 says the points A, B and C have position vectors -2, 1, 2, 5 and 6, 3 respectively. M is the midpoint of BC. Part A says find the position vector of the point D such that the vector BC is equal to the vector AD. Okay, so the first thing we can work out is what is the vector of BC. And we can work that out from the position vectors of B and C. So the way we work that out is the vector BC is going to be equal to the position vector C, which is 6, 3, minus the position vector of B, which is 2, 5. And that simplifies to 4 minus 2. Now we know the vector AD is also equal to 4 minus 2. So to work out the position vector of D, we could define D as a vector with units of, let's say, x and y, and then we could say, well, that the vector AD is going to be equal to the position vector D, which is xy, minus the position vector of A, which is -2, 1. Now, if you were going to simplify this into one whole vector, you could say that the vector of AD is equal to x plus 2 and y minus 1. And remember, the vector of AD is equal to 4 minus 2. So now we can just say that the vector x plus 2, y minus 1 is equal to the vector 4 minus 2. And now we can just solve for the values of x and y in order to work out what the position vector of D is. So we've got two equations here, so x plus 2 equals 4 and y minus 1 equals -2. So x must be equal to 2 and y must be equal to -1. So therefore the position vector D must equal 2 minus 1. Now part B says find the magnitude of the vector AM. Now we're told in the question that M is the midpoint of BC. So first we're going to need to work out the position vector of M. So M is going to be halfway between B and C. So if we were going to calculate this, it's going to be 2 plus 6, and that's all divided by 2. And then our y values are going to be 5 plus 3, and that's all going to be divided by 2. So M has the position vector 4, 4. So now what we can do is we can work out what the vector of AM is. So the vector AM is going to be equal to the position vector of M, which is 4, 4, minus the position vector of A, which is -2, 1. Now that simplifies to 6, 3. Now we need to find what the magnitude of the vector of AM is. So if I was to draw the vector AM, so we say the position vector of A is here, and the position vector of M is here, well the vector is going to be this line here. So it's going to be a certain number of units across, which is parallel to the x-axis, and a certain number of units up parallel to the y-axis. So these are going to be perpendicular, and we know what those units are because we've just worked out the vector of AM. This has a magnitude of 6, and this has a magnitude of 3. So to work out the magnitude of the vector itself, we can use Pythagoras' theorem, because it's equal to this length here. So the magnitude of the vector, which we write like this, is equal to the square root of 6 squared plus 3 squared, which simplifies to the square root of 36 plus 9. And that simplifies to the square root of 45. And the square root of 45 is made up of the square root of 9 times 5, which as a surd simplifies to 3 root 5. So therefore we can say that the magnitude of the vector AM is equal to 3 root 5. Question 5. A doctor's surgery starts a campaign to reduce missed appointments. The number of missed appointments for each of the first 5 weeks after the start of the campaign is shown below. We've got number of weeks after the start, which is represented with the variable x, and we've got number of missed appointments, which is the variable y. This data could be modelled by an equation of the form y equals pq to the power of x, where p and q are constants. Show that this relationship may be expressed in the form log of the base 10 y equals mx plus c, expressing m and c in terms of p and or q. Okay, so what we need to do is we need to rewrite the equation y equals pq to the power of x in the form log to the base 10 of y equals mx plus c. So what we can do is we can take log to the base of 10 to both sides. We can then simplify the right hand side using our log laws. So we're going to get log to the base of 10 p plus log to the base of 10 q to the power of x, and then we can bring down the power of x to the front of the logarithm. So we get log to the base 10 of y equals log to the base 10 of p plus x log to the base 10 of q. And now if you compare this against log 10 y equals mx plus c, you should be able to see that m is going to be log to the base 10 of q, and c is going to be log to the base 10 of p. So this becomes our final answer. Then it says the diagram below shows log to the base 10y plotted against x for the given data. Part B says estimate the values of p and q. Okay, so we've got 5 data points here, and what we can do is we can draw a line of best fit to represent the equation of the line that goes through each of these points. Okay, so this would look something like this, and as shown in the previous part, we know that this line has the equation log to the base 10 of y equals x log to the base 10 of q plus log to the base 10 of p. And if we compare this equation against the equation of a straight line, which is y equals mx plus c, then we should be able to estimate values for q and p. Because we know m is our gradient, so m must be equal to log 10 q, and c is our y-intercept, so c must be equal to log 10p. So what we need to do is we need to estimate what the gradient of this line is. So let's say I take the first data point and compare it against the last data point. Well, if we look at the coordinates for the last data point, that has coordinates 1, 2.4, and the fifth data point is coordinates 5, 1.6. So what I can do is I can say my gradient m, which is log to the base 10 of q, is equal to the change in y divided by the change in x. So that's going to be 2.4 minus 1.6 over 1 minus 5. And this simplifies to, type this in on the calculator, I get minus 0.2. So now log to the base 10 of q equals minus 0.2. So now I should be able to work out my value of q, because I know 10 is my base, I know q is my answer, and I know minus 0.2 is going to be my exponent. So that means I can rewrite this as q equals 10 to the power of minus 0.2. And if you type that into your calculator, that simplifies to 0.631 to 3 significant figures. Now c is log to the base 10 of p. Well, p on the graph is roughly equal to 2.5. So what we can say is that 2.5 is equal to log to the base of 10 of p. So that must mean p equals 10 to the power of 2.5. And 10 to the power of 2.5 is 316 to 3 significant figures. Part C says use the model to predict when the number of missed appointments will fall below 20. And we need to also explain why this answer may not be reliable. Well, if we look at this table, we know that the number of missed appointments is the variable y. Basically, what we need to do is we need to substitute 20 into log 10y, where y equals 20. So if we work this out, so when y equals 20, we're going to get log to the base 10 of 20. You can work that out on your calculator, and you should get an answer of 1.30 to 3 significant figures. Now, if I look at the graph, 1.30 about here. Now that's showing around 6.5 weeks, but we want to represent the number of weeks as integers. So if we say here that the number of missed appointments will fall below 20 around the 7th week. Okay, but we also need to explain why this answer may not be reliable. And the reason why it's not reliable is the model is not reliable because we are making the assumption that the model will hold true over a long period of time. And that is part C. Question 6, part A says a student suggests that for any prime number between 20 and 40, when its digits are squared and then added, the sum is an odd number. For example, 23 has digits 2 and 3, which gives 2 squared plus 3 squared, which equals 13, which is odd. Show by counterexample that this suggestion is false. Okay, so what we need to do is we need to think of the prime numbers after 23. Well, the next prime number after 23 would be 29. So that's going to be 2 squared plus 9 squared, which is 4 plus 81, which equals 85. Now that's still odd. So what about the next prime number? Well, the next prime number is going to be 31, and that's going to be 3 squared plus 1 squared, which is 9 plus 1, which is 10, and 10 is even. So this example here, this is the disproof counter example. Part B says prove that the sum of the squares of any 3 consecutive positive integers cannot be divided by 3. So if we take 3 consecutive positive integers and call them n, n plus 1 and n plus 2, now if we square them and add them together, so we're going to get n squared plus n plus 1 all squared plus n plus 2 all squared. And now if we simplify this, we're going to get n squared plus n plus 1 multiplied by n plus 1 plus n plus 2 multiplied by n plus 2. This simplifies to n squared plus n squared plus 2n plus 1 plus n squared plus 2n plus 2n plus 4. That simplifies to 3n squared plus 6n plus 5. Now what we can do is we could take out factor of 3n from 3n squared plus 6n, which is going to be n plus 2, and then we can add 5 on the end. Now 3n we know is a multiple of one of our integers, n. And n plus 2 is also a multiple of an integer that we started off with, n plus 2. But then we've got this plus 5 at the end, which means we have a remainder of 5. So what we can say is 3n multiplied by n plus 2 plus 5 has a remainder of 5. Therefore, the result cannot be divided by 3. Question 7 says differentiate f of x equals x to the power of 4 from first principles. So the first thing I like to do is I like to differentiate the function to see what result I would expect. So f of x equals x to the power of 4. So if I differentiate this, I'm going to get 4x cubed. Okay, so that's the result I'm looking for. Then what I like to do is I like to draw a graph of the function. So y equals x to the power of 4 is basically the graph of y equals x squared. It just has a flatter bottom. So it will look something like that. And let's say we've got a point here and a point up here. Okay, so I'll just extend this axis. And I'm going to call this point 1 and I'm going to call this point 2. Now point 1 has a coordinate of x and its corresponding y value is going to be function x. P2, let's say, has an x value of x plus h. So its corresponding y value is going to be function x plus h. Now the idea is when we differentiate this function at either point 1 or point 2, we're going to have a tangent at both of these points. So if I draw a tangent at point 1, and then I'll draw another tangent at point 2, what we want to do is we want to take one of the points, let's say let P1 get closer to P2, then what's going to happen is this difference of h, because there's a difference of h between x plus h and x, well h will tend to 0 once those 2 points get closer together. Now they're not going to overlap exactly, but they're going to get closer towards each other. And what's going to happen is it's going to tend to one tangent, to a single tangent. So what we can say is if P1 is getting closer to P2, then we can say that the gradient of the tangent at P2 is going to be equal to the change in y divided by the change in x. So our first y value is function x plus h. Our second y value is f of x, and then that's all over x plus h minus x. Now, and if we simplify this, we get function x plus h minus function x all over h. Now, remember up here, I said when P1 gets closer to P2, the value of h is going to tend to 0. So what I can do is I can write a limit here as the limit of h tends to 0. And this is where this formula comes from. This formula is in your formula books. So next thing we need to do is we need to define some of these values in our limit. So we know that function x is equal to x to the power of 4. And what's function x plus h going to be equal to? Well, we can work that out easily. That's going to be x plus h all raised to the power of 4. So if we rewrite our limit, we're going to get the limit of h tends to 0, which is going to be x plus h to the power of 4 minus x to the 4 over h. Now, in order to simplify x plus h to the power of 4, I'm going to use the formula for binomial expansion. So this is going to be equivalent to x to the power of 4 plus 4x cubed h plus 6x squared h squared plus 4x h cubed, and then it's just going to be plus h to the power of 4. So now what we can do is we can rewrite our limit as h tends to 0, so that's going to be x to the power of 4 plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the 4, that's going to be minus x to the power of 4 all over h. Now, and if I simplify this, I'm going to get the limit as h tends to 0 of 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the power of 4 all over h. If I then divide by h, I'm going to get the limit as h tends to 0. It's going to be 4x cubed plus 6x squared h plus 4x h squared plus h cubed. So that is my limit in its final form. Now I can evaluate the limit. If h tends to 0, then what's going to happen? We can say as h tends to 0, 6x squared h plus 4x h squared plus h cubed is also going to tend to 0. So now we're just left with the derivative of f of x, which equals 4x cubed, and that's what we worked out at the start. Question 8, a curve has equation y equals kx to the power of 3 over 2, where k is a constant. The point P on a curve has x coordinate 4. The normal to the curve at P is parallel to the line 2x plus 3y equals 0, and meets the x-axis at the point Q. The line PQ is the radius of a circle at centre P. Show that k equals a half, and then find the equation of the circle. Okay, so there's quite a lot in this question. We need to sort of break it down step by step. So if we look at the point P first, point P has x coordinate 4. Okay, so we can work out its y coordinate using the equation. So if we substitute 4 into y equals k x to the power 3 over 2, that's going to be y equals k multiplied by 4 to the power 3 over 2. That's going to simplify to y equals square root of 4, which is 2, 2 cubed, which is 8, so that's y equals 8k. So the y coordinate of P is 8k. Then we're told the normal to the curve at P is parallel to the line 2x plus 3y equals 0 and meets the x-axis at the point Q. Okay, so we can work out the gradient of the normal using this equation 2x plus 3y equals 0. So we need to rearrange it in the form of y equals mx plus c. So if we minus 2x from both sides, we're going to get 3y equals minus 2x, and then divide both sides by 3. We're going to get y equals minus 2/3 of x. Now we can say that the gradient of the normal at P equals minus 2/3. Now we're also told that the normal to the curve at P meets the x-axis at the point Q. and then the line PQ is the radius of a circle. So what that means is that the line PQ must be perpendicular to the normal. And remember, we know that the tangents are perpendicular to the normal. So what we can say is the gradient of the tangent at P, well, that's the negative reciprocal of minus 2/3, which is going to be 3/2. Now, we've got the equation for the curve, which is y equals kx to the power 3/2. Now, if we differentiate this, so dy by dx, that's going to equal 3/2 kx to the power of a half. Now, we know what the gradient of this function is, because we've just worked out that the gradient of the tangent at P is 3/2. So if we make this equation equal to 3/2, then we should be able to solve for k. Because if we divide both sides by 1.5, we're going to get 1 equals kx to the power of a half, and then we know what x is at point P. X has a value of 4, so we can substitute our value of 4 in. So when x equals 4, we're going to get 1 equals k multiplied by 4 to the power of a half. That's going to simplify to 1 equals 2k. Divide both sides by 2, you get k equals 1/2. So there we've shown that k equals a half. Now we need to find the equation of the circle. So first thing we can do is we can simplify point P, because we said P was the coordinate for a k, but now we've got a value for k. P is going to be 4, 4. So to work out the equation of the circle, first I want to work out what point Q is. Okay, and I can do that by working out what the equation of the line PQ. So the equation of the line PQ is going to be in the form of y minus y1 equals m bracket x minus x1. Remember, we know that the gradient of PQ equals minus 2/3. So if we substitute these values in, we're going to get y minus 4 equals minus 2/3 of x minus 4. If we simplify this, we get y minus 4 equals minus 2/3 of x plus 8/3. Add 4 to both sides, you get y equals minus 2/3 of x plus 20/3. Now remember, we're told in the question that the normal to the curve meets the x-axis at the point Q. Well, it meets the x-axis when y equals 0. So when y is equal to 0, we can say that 0 equals minus 2/3 of x plus 20/3. And then we can solve to get 2/3 of x equals 20/3. So x therefore equals 10. So the point Q has coordinates 10, 0. Now, because we've got our coordinates for point Q and our coordinates for point P, we can now work out what the length of the line PQ is going to be. So if I draw this visually, we could have, say, P here, and then Q might be down here. So that's 4, 4, that's 10, 0. So you should be able to see that we can use Pythagoras' theorem to work out what the radius is. So that's 4 units there, and then it's 6 units along. So using Pythagoras, it's going to be PQ equals the square root of 6 squared plus 4 squared, which is 36 plus 16. This simplifies to the square root of 52, which simplifies to 2 root 13, so that's r squared. Now, the equation is going to be in the form of x minus a squared plus y minus b squared equals r squared, where the coordinates a, b is the center of the circle, and r is the radius, so that's the general form for the equation of a circle. So we're told that the centre is at P, and P has coordinates 4, 4, so it's going to be x minus 4 all squared plus y minus 4 all squared equals r squared, which is 2 root 13 squared. And if you simplify that, you get x minus 4 all squared plus y minus 4 all squared equals 52. And that is our final answer. Okay, so now we've reached section B, which is the second section of the paper. It's the mechanics section. So question 9 says the diagram below shows a velocity time graph of a car moving along a straight road, where v meters per second is the velocity of the car at time t seconds after it passes through the point A. Part A says calculate the acceleration of the car at t equals 6. So t equals 6 is at this point here. So the way we need to think about this is, let's define acceleration. Acceleration is the rate of change of velocity, okay? And when we describe rates of change, we're talking about the gradient. So the acceleration must be the gradient of the velocity time graph. Now in here we've got this downward slope. And what that suggests to me is that there's constant deceleration between t equals 5 and t equals 8 here. What that means is the value for the acceleration is going to be the same between t equals 5 and t equals 8. So what that means is, if we were going to work out the gradient, we would probably take this point here, which is the point 54, and this point down here, which is 8, 0, and then work out the gradient. So we say A for the acceleration. Now it's change in y divided by change in x. So we will probably go down 4 units, so negative 4 units, and change in x we would go along 8 minus 5, which is 3. So this simplifies to minus 4 thirds. Now what that means is the deceleration is 4 thirds meters per second squared. But acceleration can take positive and negative values. So the acceleration at t equals 6 is minus 4 thirds meters per second squared. Part B says Jasmine says the distance travelled by the car during the first 20 seconds of the car's motion is more than 5 times its displacement from A after the first 20 seconds of the car's motion. Give evidence to support Jasmine's statement. Okay, so we need to work out the distance travelled during the first 20 seconds, and we need to work out the displacement. So okay, remember, distance is equal to speed times time. We know this from GCSE. So with a velocity time graph, the distance is the area under the graph. Now the difference between distance and displacement is distance is a scalar quantity, which means that it only has a magnitude. Displacement is a vector quantity, which means it has both magnitude and direction. So what that means is, with regards to displacement, when the graph gets below v equals 0, when the velocity becomes negative, the car is changing direction. So the displacement is going to be negative under the t-axis. Whereas for distance, because there's no direction, it doesn't matter whether we're travelling forwards or backwards, the distance is whatever the distance is we've travelled. If we work out the distance first, well, here we've got a square. So 5 times 4 is the area there. Now here we've got a right angled triangle. That's 3 units across by 4, so that's going to be plus a half times 3 times 4. Now, to split this into 2 triangles here, 2 right angled triangles down here. This is 12, so this has a base 4 here, and then here we're going to have a base of 8 and a height of 3 here. So we can add a half times 4 times 3, and then we can add a half times 8 times 3. So if we simplify this using our calculator, we get 5 times 4 plus half of 3 times 4 plus a half of 4 times 3 plus a half of 8 times 3. And that all simplifies to 44. Now the displacement. Remember, it's a vector quantity, so we need to consider direction. So what's going to happen here is all of our values are going to be the same, but some of them are going to be positive and some of them are going to be negative. So the values above our t-axis is going to be positive and the values below it are going to be negative. So all we're doing is we're just doing 5 times 4 plus a half of 3 times 4. Then we can take away a half of 4 times 3 and then take away a half of 8 times 3. And if you simplify that on your calculator, you should get an answer of 8. And these are both in meters. Now, the question said that the distance travelled by the car during the first 20 seconds of motion is more than 5 times its displacement. So what we can do is we can take our distance, divide it by our displacement, and see how many times more our displacement is compared to our distance. So 44 divided by 8, that simplifies to 5.5. 5.5 is more than 5 times, so we can say yes, the distance is 5.5 times the displacement. Question 10 says a student is attempting to model the flight of a boomerang. She throws a boomerang from a fixed point O and catches it when it returns. She suggests the model for the displacement s meters after t seconds is given by s equals 9t squared minus 3 halves of t cubed, where t is between 0 and 6. For this model, part A says determine what happens at t equals 6. So if we substitute t equals 6 into this equation, so we get s equals 9, 6 squared minus 3 over 2, 6 cubed. What should happen is we should get an answer of 0 for our displacement, which is correct. What we can say is when t equals 6, this is the point at which the student catches the boomerang. So what's going to happen is at t equals 0 and t equals 6, t equals 0 being the point just before she's about to throw the boomerang, and t equals 6 being the point at which she catches it, the boomerang is still in its starting position. It hasn't moved anywhere. So its displacement is always going to be 0. So that's part A. That was nice and straightforward. Part B says find the greatest displacement of the boomerang from 0. Now the greatest displacement is going to be when the velocity of the boomerang is equal to 0. So we can say when v equals 0, so what's going to happen is we are going to need to differentiate our displacement function, because velocity is the rate of change of displacement. So remember, s equals 9t squared minus 3 halves of t cubed. So ds by dt, which is equal to v, is going to equal 18t and minus 9 halves of t squared. So this is v equals 18t minus 9 over 2t squared. So remember, v equals 0 if we want to find the greatest displacement. So that means we're going to get minus 9 over 2t squared plus 18t equals 0. We can factorise out t, so we get minus 9 over 2t plus 18 equals 0. So one of our values for t is going to be equal to 0. The other value is going to be 18 equals 9 over 2t. So we simplify that by doing 18 times 2, dividing that by 9, we'll get t equals 4. So t equals 0. So if I move this down, we're going to have t equals 0 or t equals 4 for our two values of t when the velocity is equal to 0. So now what we need to do is we need to substitute these values of t into our displacement equation. Now, I'm not going to substitute t equals 0 because I know that's going to give us a displacement of 0, which is not the greatest displacement we could have. The greatest value must be when we substitute t equals 4. So we can say when t equals 4, we're going to get s equals 9 multiplied by 4 squared minus 3 halves multiplied by 4 cubed. And if we simplify this on our calculator, we get an answer of 48 meters, which is our greatest displacement. Part C says find the velocity of the boomerang 1 second before the student catches it. Well, 1 second before the student catches it would be when t is 5 seconds. So basically we're going to use our velocity function, which we worked out in part B, which is 18 t minus 9 halves of t squared, and we're going to substitute when t equals 5. So v equals 18 multiplied by 5 minus 9 halves of 5 squared. So we simplify v, we get minus 22.5 meters per second. Now part D says find the acceleration of the boomerang 1 second before the student catches it. Okay, so remember, acceleration is the rate of change of velocity. So what that means is if we differentiate our velocity, it's going to give us our acceleration. So we know v equals 18t minus 9 halves of t squared. If we do dv by dt, which is equal to the acceleration, we're going to get 18 minus 9t. And then we just say when t equals 5, because that's 1 second before the student catches it, our acceleration is going to be equal to 18 minus 9 times 5. If we simplify that, we get minus 27 meters per second squared. So that's our final answer. Question 11 says, in this question, the unit vectors I and j are in the directions east and north respectively. Distance is measured in meters and time in seconds. A ship of mass 100,000 kilograms is being towed by 2 tugboats. The cables attaching each tug to the ship are horizontal. One tug produces a force of 350 I plus 400 J newtons. The other tug produces a force of 250 I minus 400 J newtons. The total resistance to motion is 200 newtons. At the instant when the tugs begin to tow the ship, it is moving east at a speed of 1.5 meters per second. Part A says explain why the ship continues to move directly east. Okay, so I think the first thing to do with questions like this is to draw a diagram. So what's happening is we've got 2 tugboats which are pulling one big ship. So I'm just going to represent these with rectangles. So this here is my ship, and then I've got 2 cables. We're told that the cables attaching each tug to the ship are horizontal, so I can just draw them like this. Now I can draw 2 smaller rectangles to represent the tugboats. One can be like that. And the other could be like that. Now, we're told that one tug produces a force of 350I plus 400J. So if I draw those forces on, that means we're going to have 350 newtons acting in the east direction, and then 400 newtons acting north. Now, there would be some resultant force here between them, but we've got to consider the second tug. So the second tug has 250 newtons acting east, and then it has 400 newtons acting south. And we're told that the total resistance to motion is 200 newtons. So I can draw that here. And then we're told at the instant when the tugs begin to tow the ship, it is moving east at a speed of 1.5 meters per second. Okay, we don't need that for the first part of the question. So first part says we need to explain why the ship continues to move directly east. This is all to do with resultant forces. If we have a look at resultant forces in the I direction, then what happens is we've got 350 newtons plus 250 newtons minus 200 newtons. And that simplifies to 400 newtons. And that is moving east. Now, resultant forces in the J direction, we've got 400 newtons acting north, and we've got another 400 newtons acting south. Well, that's just going to be 400 newtons minus 400 newtons, which is 0 newtons. So what we can say is there is 0 resultant force acting in the J direction. So neither of tugboats are moving north or south. Therefore, the overall resultant force acts 400 newtons in the east direction. Now, part B says find the acceleration of the ship. Now, using Newton's second law, we know that force equals mass times acceleration. Well, the total resultant forces in this case, we know are 400 newtons acting eastwards. So we can say we've got total forces of 400 newtons. That's equal to our mass, which we're told in the question is 100,000 kilograms, and then multiply by A. So we can rearrange to find A. So A is 400 over 100,000, and this simplifies to 0.004 meters per second squared. Part C says find the time which the ship takes to move 400 meters while it is being towed, and then we need to find its speed after moving that distance. So to find the time taken after it's moved 400 meters, we can use SUVATs. So S, which is our displacement, is going to be 400. U, which is the initial velocity, we are told in the question. We're told at the instant when the tug begins to tow the ship, it is moving east at a speed of 1.5 meters per second. So that is our initial velocity. V, our final velocity, well, we don't know our final velocity yet. And AR acceleration we just worked out in the previous part, which is 0.004 meters per second squared. And time is what we're trying to work out. So we need to find a Suvat equation which doesn't involve v, where we're trying to find t. And that is the Suvat equation s equals ut plus a half at squared. So we substitute our values into this equation. So half of 0.004 is plus 0.002 t squared. Now we need to solve values for t. Now what you can do is you could use the quadratic formula to work this out, or you can use your Casio ClassWiz calculator to work out the answer. So if I rewrite this as 0.002 t squared plus 1.5 t minus 400 equals 0, and what I can do is I can go to my calculator, press menu, scroll down to A where it says equation / function, select that. Then I can select 2 to solve polynomial equations. Then we've got a polynomial degree of 2, and then I can just enter my values. So I'm going to have 0.002, 1.5, and minus 400. And when I press enter, I get my first t value as 209 seconds to 3 significant figures, and my other value of t is minus 959 seconds to 3 significant figures. Well, I know time can't be negative, so the only time I must be dealing with is the 209 seconds. And the next part of the question said find its speed after moving that distance. Well, at speed, we can use Suvat again. So its distance is still going to be 400. U is still going to be 1.5. V is what we're trying to find. A is 0.004, and in this case I don't need t. So I need to find a Suvat equation which doesn't involve t, where I need to find v. So the Suvat equation for that is v squared equals u squared plus 2as. So I can substitute my values into here, so I get v squared equals 1.5 squared plus 2 multiplied by 0.004 multiplied by 400. And if I simplify this, my calculator, I get v squared equals 5.45, and I can just square root both sides to get v equals 2.33 meters per second to 3 significant figures. And that was the final question. Thanks for watching the video, guys. Don't forget to subscribe to my channel. I've also left a link in the description to my website so you can download both the exam paper and the mark scheme from this video. And you can also check out any other videos from my YouTube channel on this page.